Alright guys, welcome back. We have another question from the second chapter of Engineering Mechanics by Meriam, and we have this 70-meter microwave transmission tower that is steadied by 3 guide cables as shown. We know the cable AB carries a tension of 12 kilonewtons, and we need to express the corresponding force on point B as a vector. So we have to figure out the force that is applying on B, and we have the information about cable AB, which means we don't care about AB and AD and AC. And because the cable can only be in tension, so the cable by itself, I'm just going to show it in here, this cable AB will be in tension. So the force on two ends kind of pull the cable. That means the force that is applying from point B to the cable is this force that I'm showing in here. But the question is asking for the force that is applying to the point B. So based on the Newton's law, there's going to be another force, same as this one, just in the opposite direction at point B. And let's call this force here maybe TBA, meaning starting from B and the ending is at A. So that's the first thing for the direction. So we need to keep in mind that the correct direction that is applying at point B is this direction, and the rest of this is the video that we talked about in the previous videos on the other channel. I'm going to put the link in the description below. Basically, our tension in the cable UABA in a vector form would be the magnitude times the unit vector BA. The tension is unknown in the question. We know it's 12 kilonewtons, so all we need to do in here is just to find the unit vector BA, and that should give us the final tension that is applying at point B in a vector form. So that's going to be 12 kilonewton times. So what we need to figure out for the unit vector of BA, we need the coordinates of the ending point, which is our A, and coordinates of the starting point, which is B, and our BA would be basically A minus B, and we have XYZ for each. So let's figure out the XYZ for each of them. If you look at the A, we can see that the point is on the Z-axis, meaning there is no X and Y, and the Z would be this height, which is 70. B is a bit trickier because we have a value for each of them, X, Y, Z. So let's start with the X. We can see the point B is this much on the positive side of the X, and that value is going to be what we have in here, 35. Looking at the Y, we can see that we are on the negative side of the Y, and what happens is we're going up 10 meter right above the x-axis, and we're going to go toward the negative direction of the y, and that would be 25. So negative 25, and our z would be this little height, which is 10 meter, and obviously it will be positive because it's on the positive side of z. So very simple, 0 minus 35, negative 35, 0, negative, negative 25, 25, and 70 minus 10. That's going to be 60, and that's going to be our ratio in here, negative 35x plus 25 for the y component, j, and plus 60. And once we figured it out, the denominator is pretty straightforward. What's the magnitude of the vector that we have in the numerator? So square root of 35 squared plus 25 squared plus 60 squared. Again, feel free to check that video out, just explaining the details of this more. And yeah, the rest of this is just calculating this. Let's get our ratio here. So first of all, we have 12 times this ratio where the denominator is the same, 35 squared plus 25 squared plus 60 squared, and on the top we have negative 35. That's going to be our x, so negative 5.69. That's going to be our I. We have 25 for the j, which is going to be 4.06. And the last one is 60 plus 9.75. Okay, and the unit is going to be in kilonewton. And yeah, that's going to be the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. Again, I'm going to put the tutorial for the unit vector in the description below, just in case. And yeah, you guys take care. I'll see you in the next video. Have a good one.